So in the last video, we stopped at that this negative 0.8 over 1 or 0.8 over negative 1 is one and the same thing, right? As we can see. So this one is that you move positive 1 in the horizontal direction and negative 0.8 in the horizontal in the vertical direction. So the line goes like this. Okay, and if it is a point, so from here you're moving, and this one is that you move negative 1 unit in the horizontal direction and then positive 0.8 unit in the vertical direction, right? So again the line is going to be like this. So this is one and the same thing. As you can see that they both are parallel to each other, right? So the general formula to find out gradient between any 2 points A and B, where A is x1 comma y1, and it can't be that A is x1 comma y2. Never do that. So this is x1 comma y1 and B is x2 comma y2, right? So the formula is going to be y2 minus y1, which is change in y, upon x2 minus x1, and it is one and the same thing if you do y1 minus y2 upon x1 minus x2. Now if you're taking y1 here, you ought to take x1 here, right? And if you're taking y2 here, you ought to take x2 under it, right? Now, so a zero gradient means that it is a flat curve, which means what? This means that it's a horizontal line. There is no change in the vertical axis. So this is a line like this. So if it is k, so you will write down y equals to 0x plus k, right? So we will come to the equations of a line in a bit. Now, so and what does undefined mean? So undefined is when you're dividing by 0, right? So if your gradient is something upon 0, so change in y upon 0, that is that your x is not changing, but your y keeps on changing. So what does that mean? That means that this is a vertical line, x is equal to p or something, right? That now you can see that if you're moving from A to B, change in y is these many units. Let's call it k. So change in y is k, but change in x is just 0. So this is undefined, right? So the equation of this does not involve y. The equation of this line is just going to be x is equal to p, where p is going to be the x-intercept, right? So it's a vertical line. A lot of teachers ignore it, but Cambridge does not. Now let's try to solve. Now let's do an examiner shortcut. What if you have a negative denominator, right? So just like we did earlier, that if you have negative 0.5, so that means it is negative 1 upon 2. So you can also rewrite it as 1 upon negative 2. So now this means that it is moving minus 2 units to the left and then 1 unit up, right? So you're moving from here to here, okay? So we now can see that if gradient measures steepness. So gradient is a parameter for how steep the line is between 2 points, right? But if gradient measures the steepness, then what happens if two roads, so if there's a road from A to B and if there's another road from C to D, let's say the steepness between C to D is exactly the same as well. What happens then? This brings us to the idea of parallel lines, okay? So parallel lines. Now the property of parallel lines is that their gradient is the same. So on a Cartesian plane, if there are two lines which are going exactly in the same direction, which means that they're parallel, if you know exactly that they're never going to meet each other on a Cartesian plane, right? So we say that the slope or the gradient of these two lines is the same. Now, why is it so? Because the change in y and change in x, the ratio of these two is exactly the same, okay? So it could be 2 over 4, or it could be 4 over 8, or it could be 1 over 2. I mean, however small the triangle you take, the ratio is still going to be the same of the two sides, okay? Now it doesn't happen because formula says so, but because they rise equally, right? So if you move 2 units to the right, it moves 1 unit up. If you move 4 units to the right, proportionately it moves 2 units up. If you move 8 units to the right, it moves 4 units up, right? So it is exactly the same. Now So that's about parallel lines, that their gradients are the same. Now what happens if the gradients are such that the lines intersect each other at 90 degrees? Then such lines, let's call this line AB and let's call this line CD. Then the gradient, then line, let's call this line 1 and let's call it line 1. Then line 1 is said to be perpendicular to line 2 if they intersect at a right angle triangle or at 90 degrees here, right? So the intersection point has a 90 degrees between themselves, right? Between them. Now, a lot of teachers say that you flip and change sign. Don't do that, okay? Now, if so, we are not going to get into the derivation of that, but see, if this is a line at 45 degrees and there's another line at 135 degrees, right? Let's say, so this point, so you can see that this is going to be, so this is going to be 45 degrees as well, and this is 135 degrees. Now this is the line y equals to x and this is the line y equals to negative x. So we can take a coordinate. So if I take a coordinate here, so this is going to be, let's say, 4 comma 4, and if I take a coordinate here, then this is going to be negative 4 comma 4. Now, if I take the gradient of this green line, then this is going to be the gradient between origin and this point P, and the gradient for this orange line is going to be the gradient between O and Q, right? So the gradient of OQ is going to be equal to 4 minus 0 upon 4 minus 0, that is going to be 4 upon 4, that is just 1, right? And this green gradient between O and P is going to be negative 4 minus 0 upon negative 4 minus 0, which is going to be negative 1. So the product of these is always going to be 1 times minus 1 is always going to be negative 1. So the basic, so we are still not getting into the derivation because that's not part of your syllabus. The product of the gradients of two perpendicular lines, so if this is line 1 and this is the gradient for line 2, then their product is always negative if L1 is perpendicular to L2. Make sure that you always remember, right? And it's very easy that if line, let's say, if L1 is perpendicular to L2 and gradient for L1 is 2, then you can just take the negative reciprocal and the gradient for L2 is going to become negative 1 over 2. So this is negative and reciprocal, okay? So always make sure that if you have to find the gradient of the perpendicular line, then this is just the negative reciprocal of the original line, okay? So if the gradient is 2, the perpendicular gradient is negative half. If the gradient is negative 3 over 5, if the gradient of line 1, if the gradient of line 1 is negative 3 over 5, and if L2 is perpendicular to L1, then the gradient of L2 is going to be minus 1 over minus 3 over 5, which is going to be nothing but 5 over 3. Okay, I hope you have understood it. Now, what the mistake that students make and examiners always cry about in their reports is that students only flip. So if the gradient is 2 for a line and if another line is perpendicular to it, they just do 1 upon 2 and they forget to put this minus sign, which is absolutely important, because if it is 2, so the 2 gradient is going to be like this, that there is a change of 2 units in y with a unit change in x, right? Now, if you make this into half, the line is just going to become like very gentle, but it's not perpendicular. It's perpendicular when you make it gentle and you make it negative. Can you see? So this is gentle and this is negative. So now these two are perpendicular. Okay. Now we know where a line goes, how steep it is, And so let's now build the equation. Now equation, a general form of a equation of a line is, yeah, that's right, y equals to mx plus c, where now we say that m is the steepness or the gradient or the slope of the line, and c is the y-intercept. Now why are these two parameters essential to describe the equation of a line? I'll wait for you guys to think about it in your head first. Now hopefully you came to the right conclusion. Basically, if you only had gradient, let's say you have a gradient of 1, now that one gradient line can go like this, can go like this, so it's a set of a lot of infinitely parallel lines, right? So it is like this, and then another line like this, and then infinitely many lines, right? However, how will you make sure that we are talking about this particular pink line that's passing through this? That's this. So we can only make sure that it is anchored at this particular point if we can determine, or if we can log this position at which it cuts the y-axis. Therefore, we must, along with the gradient, we must have the y-intercept as well. Or let's say if we only had the y-intercept and not the gradient, let's say the y-intercept is at c. Now there are infinitely many possibilities of a line. So there could be a line like this, a line like this, a line going in this direction, right? A line going in that direction. So infinitely many possibilities of different rotations of lines passing through the same y-intercept, right? Therefore, we must log that, okay, the line is passing through this particular point, but it is going in this particular direction, right? So we will then ignore all the rest and we will say that we are just talking about this particular line, okay? So now, we know that m represents the gradient and c represents the y-intercept. Now, let's say that if you have the gradient given as 2 and you have the y-intercept at 0 comma 4, so you can just write down the equation as y equals to, the gradient is 2, so 2x plus the y-intercept is at 4, so y equals to 2x plus 4. Now let's say that you're not given the gradient, you're just given 2 points, you're given 1 comma 4 and 7 comma 8, right? Now in order to find the gradient of this line which is passing through a and b, what you can do is you can find the gradient first of a line that's passing through a and b. So that's going to be 8 minus 4 upon 7 minus 1, so that is going to be 4 upon 6, which is nothing but 2 upon 3, right? Now, so you have the gradient, so y equals to, so the general form is y equals to mx plus c. So in place of m, you're going to write 2 upon 3x plus c. Now you have an equation in y and x, but still a c, the y-intercept is unknown. How can you find that? Now you know that this particular line passes through this as well as this. So whichever point you put here, and you can try with both of them, you will find out that c is going to come out as exactly the same. Now I'm going to use b and I want you guys to put a, and let's hope that we are find, and not let's hope, 100% we are going to find the same value of c. So now let's put c, I will put point b here, okay, 7 comma 8. So 8, y is 8, x is 7, so 2 times 7 upon 3 plus c. So this is going to become 8 minus 14 upon 3 is equal to c, or 10 upon 3 is going to be equal to c. So we are going to say that y equals to 2 upon 3x, which was from here, and then now we do have the value for c as well, so this is going to be plus 10 upon 3. So we can take the, so this is the actual form of the equation. You can leave the answer here, or you can simplify it to 3y equals to 2x plus 10. That is exactly the same. Now you may also be given a question where it says that, so there's another example which says that a line is, so find the equation of L1 which is parallel to 5y minus 2x or plus 2x is equal to 11. Now, so this L1 is parallel to this line and passes through a coordinate through p, which is 8 comma 3, right? So now what do? So first of all, you know that there is a particular line this, so let's find out what its gradient is going to be. So this is going to be 5y equals to negative 2x plus 11, or y equals to negative 2 upon 5x plus 11 upon 5. So the gradient is right here, negative 2 upon 5. So we know that this line L1 will also have the same gradient. So this line L1 is going to be y equals to mx. M is minus 2 upon 5, which is parallel to this other line which it is parallel with. So minus 2 upon 5x plus c. Now in order to find the value of c, we are going to put the a particular coordinate through which this line is passing, which is p, that is 8 comma 3. So I'm going to put 3 in place of y, and I'm going to put 8 in place of x. So this is going to become 3 plus 16 upon 5 equals to c. Okay, so this is going to give me 31 over 5 equals to c. So I'm going to plug this value in here. So this becomes y equals to minus 2 upon 5x plus 31 upon 5, or I can rewrite it as 5y plus 2x equals to 31, and that's it. Now the examiner loves testing you on the perpendicular bisectors, okay? And while we are doing it, I hope you guys are going to your Cambridge endorsed book and doing all the questions in the exercises which are relevant to this chapter, right? So because do understand that wherever you learn from, whichever YouTube lecture you watch, unless you're practicing enough, you're not going to be making any progress in your understanding, right? So solving the question, really solving the practicing the exercise questions in your book exercises is absolutely essential. Okay, now let's come to the perpendicular bisector. Now perpendicular bisector shows us two things. So we have already covered perpendicular. We know that if we are given an equation, so we can find out what its gradient is, and then taking the negative reciprocal, negative 1 upon m, we can find the gradient of the perpendicular. So that's absolutely easy. Now we have also done the bisector. So let's say that you have to find the equation of a line that is a perpendicular bisector to the line AB. Now if you have A and B, so what we are saying is that there is another line that's passing through the middle such that it's bisecting A and B into two equal halves. Therefore it is passing through the midpoint of A and B, and if this is m, the gradient is m of AB, so the gradient of this line is going to be negative 1 upon m of AB. Let's do an example. Okay, so let's do an example. Let's say that there's a point A which is 1 comma 4, and then there's a point B which is negative 8 comma 11. You have to find the equation of a perpendicular bisector of, so PB of AB. So first of all, so this is at 1 comma 4. So A point is here and B point is at negative 8 comma 11. Let's say that this is 11. Okay, we may have to move it up. Yeah, we certainly do. Okay, so this is point B, which is minus 8 comma 11, and this is A, which is 1 comma 4. So we have to find the equation of a perpendicular bisector of AB. That's, so perpendicular bisector means what? That this is a line which is intersecting at 90 degrees. So the gradient is minus 1 upon gradient of this black line, and it is passing through a point such that it is bisecting the line AB. So let's call this the midpoint of AB. So the midpoint of AB is going to be minus 8 plus 1 upon 2 and 11 plus 4 upon 2. So this is 15 upon 2 and this is negative 7 upon 2. So we will say that the midpoint is negative 7 upon 2 and 15 upon 2. Okay, so we know where this yellow line is passing from. Now we just need to find out the gradient of this line. So we cannot find the gradient of this yellow line directly. So instead we will find out the gradient of this line, and the gradient of line AB is nothing but y2 minus y1. So 11 minus 4 upon x2 minus x1, minus 8 minus 1 is minus 9. So 7 upon minus 9. So if the gradient of this line is minus 7 upon 9, so the gradient of this line is going to be 7 upon 9, 9 upon 7, negative reciprocal, right? So negative gets omitted and the and this gradient flips. So 9 upon 7 is going to be the gradient of this. So if we have to find the equation of a line, so this perpendicular bisector equation is going to be y equals to m, which is 9 upon 7x, plus c, we don't know what c is. So we are going to plug in this midpoint which this perpendicular bisector is passing from. So y is 15 upon 2, 9 upon 7, x is minus 7 upon 2, plus c. So 7 cancels 7. So this is minus 9 upon 2. So it becomes plus 9 upon 2 here. And this is the value of c. So c is nothing but 12. So we are going to plug this in here. So y equals to 9 upon 7x plus 12. So this is going to be the equation of our perpendicular bisector, and that's it. Now, so this is what we had to do. We have so we did, first of all, we did the midpoint. Then I'm now recapping the entire progression of this lesson, including the part A of this lesson. This is second part of the same lesson, and after this one we are going to do the third. We are going to do coordinate geometry part 2, which involves figures and all of that, right? And solving equations simultaneously in order to find the equation, in order to find the unknown coordinates. Now, first of all, we found the midpoint, which was nothing but the average of the vertical and horizontal coordinates. Then we found the distance, which was just through Pythagoras theorem. So this was midpoint. Then we did distance, which was through Pythagoras theorem. Then we did parameter questions in which we found the equation of the gradient and the y-intercepts. And then we also did the perpendicular bisector, and then we did a mixed problem. Now, the common mistakes that students do is that they do the wrong order. They do x2 minus x1 and they put y1 minus y2 here, and when they're trying to find the gradient between 2 points, which is x1 comma y1 and x2 comma y2. So you can't do that. I told you that if there is a y1 here, that underneath is going to be x1. Okay. Now, second, you forget brackets when you're doing all of this, right? So make sure that you are never doing that. Okay. Now, and sometimes the students expand too early. Never do that. Never forget the negative sign whenever you are finding the gradient of a perpendicular bisector. Also, sometimes the students use midpoint instead of the distance, right? So don't do that. And so and a lot of times that students forget to find the vertical gradient and or call it undefined. So if you have a line that's passing through a particular point vertically, then the gradient of this is going to be undefined. So if you don't do it, you're going to lose marks as well. Or and another mistake is that students find the wrong intercepts for y, right? So today we learned the midpoint, distance, gradient, parallel and perpendicular lines, how to form the equation of a line, how to use the point gradient form, which is if you are given a gradient and the y-intercept which it is passing through, so you can directly form the equation of a line. And also we did how we find the equation of a perpendicular bisector. Now notice something, everything came from just one picture, 2 points. That's the whole chapter. Now today's lesson covers every straight line tool you'll need for Cambridge, but we are not done with coordinate geometry. This was just part 1. In the next lecture, Cambridge starts becoming much more interesting because we'll be solving parameter questions, we will be finding unknown coordinates, we will be finding the points which are equidistant, and we are going to see it all through the hidden geometry inside of it, and we are also going to do questions that combine every idea you have learned today. So we will be consolidating everything, and after that we will begin one of the highest scoring topics in pure mathematics, and which is going to be circles. So make sure you have completely mastered today's lesson before moving on. If this lecture helped you, subscribe, share it with someone preparing for AS Mathematics, comment under it, and if you are aiming for an A in 9709, I'll see you in the next lesson. You can also follow us on our Instagram, and our handle is Easy Taleem, EASYTALEEM. And if you have any queries and you want a free solution of that, you can reach out to me on my WhatsApp +92 329 3028 485. and I will see you in my next lesson. Thank you.